All right, good morning, good afternoon, good evening, depending on where you are. Welcome to the LEOMO Running MPI launch. My name is Brian Metzler. I'm the marketing director here at LEOMO, and we're excited to launch our latest application, sports innovation. LEOMO is a Boulder, Colorado-based company founded in 2012 by Kunihiko Kaji and Taizo-san. We also have a satellite office in Tokyo, Japan. We do various engineering in both places and also marketing and production in Boulder. We were started and continue to be a company focused on innovative sports technologies, devices, and services, specifically right now in the endurance sports sector. We have a company motto of precision makes perfect. What does precision makes perfect mean? We believe that training with precision based on digital insights is a crucial piece to athlete development, and we believe it's a final piece to the performance puzzle. Obviously, we train a lot of different ways, we do a lot of different things, but certainly we believe that these digital insights are the way to really fine tune and make the final push into performance. Today's discussion will be about running MPIs, which is a way to look at running form in a digital format like never before. It is based on our Type-S device, which I'll get into in a minute. That was launched in January, initially with cycling performance applications, and now we're proud to launch our running form analysis tools. Why is running form analysis important? Obviously, if you've been a runner, if you've been a coach for years, you've been understanding how to improve your efficiency, your running economy. Obviously, running more efficiently, running stronger, running healthier, running faster. Ultimately, we all want to run faster in races, and certainly injury prevention and the ability to track injury rehabilitation. Certainly through the years, we've all found different ways to understand our form. Again, coaches and doing drills and a lot of different things, but certainly we believe this technology will allow us to take the next step. And to that point, quantifying athlete movement gives precise numerical values to motion. This gives the ability to explain, compare, track performance, and make improvements. This highlights real differences, which helps to pinpoint structural imbalances and muscular weaknesses in an athlete, while also determining the most efficient and powerful way to move. And again, all runners, all athletes are different. If you looked at a marathon or a 10,000 meter race on the track, we'd see a lot of similar talents and similar speeds and similar efforts, and probably a lot of people that train the same way. The one difference we'd see is that running form for all those athletes is entirely different, whether it be how their arm moves, their torso moves, their legs move. And certainly at some level that talent is the most important piece, but we also know that refining that movement, making it more precise is a way to improve, whether you are an elite athlete on the world stage or a recreational runner. As I mentioned before, Type-S is our device that we launched in January at the Consumer Electronics Show. And like I said, we're proud to announce it as a running device. What is a Type-S? It's a multi-function device that tracks running data, also obviously tracks running form motion analysis, and is also an Android phone, a fully functionally Android phone. As a run tracking device, the Type-S can track all the traditional metrics that we all use: speed, pace, cadence, distance. It also pairs with ANT plus devices, for example, heart rate monitors. It is Wi-Fi enabled. It has 2 Bluetooth chips. One links directly to the IMU sensors, which we'll get into in a little bit, that are placed on the body. And then one can also link to other third-party devices, for example, if you're running with wireless headphones. It also auto-syncs to Training Peaks and Strava. So if you're already training with those services, you can obviously link right from Type-S to those services and see your data. The biggest thing that we're talking about here today with our MPIs is real-time motion analysis. Our technology works with the Type-S unit. We have 5 IMU sensors that are placed on the body in specific places to be able to track the data of those specific movements as that part of the body moves, but also in relation to a specific part of the gait. It can track in real time and give back immediate data for improvement. You can make small changes, small cues, small postural changes to change how you're moving, how you're running. For example, if you're late in the stage of a marathon, we all know that if you change your form to, for example, run more upright, you can obviously make significant changes that way. This is many steps deeper than that, offering you the digital data to show many aspects of your gait. Also, aside from the real-time results, you can take this data and obviously track and improve over long term with structural changes, strength training, drills, things like that. And the data is recorded and obviously easily interpreted post-run via our web application, which I'll get to in a second. It is also a fully functioning Android mobile phone, as I mentioned before. It has a SIM card slot, and so you can use it as a phone to call and send texts and emails. You can also get all your third-party apps from the Google Play Store. That means you can load Strava, Training Peaks, Map My Run, whatever you want, Swift, Spotify, all these things that you normally train with right here on your Type-S. It also has 2 cameras in the front and the back. You can take high-quality images, videos, and obviously have those later, just like we do on our runs already. As I mentioned, the Type-S, or the LEOMO web app the LEOMO application on the Type-S is basically your interface to track all your data in real time. It allows you to get an understanding of kind of how you're performing based on the data that comes through the IMU sensors that are placed on your body. And so in real time, you can check in during the middle of a workout and see what your stride is doing. You can see how you're performing. You can obviously, between intervals, make improvements and also enhance performance on the fly. It also tracks traditional running data. So again, if you're looking at pace, cadence, distance, splits, those kind of things in a workout, whether you're on the road or whether you're at the track, you can cross-analyze those with the running motion data as well. The Type-S is small. It's smaller than palm size. It weighs 110 grams. If you were to see it, which you will in a second, it's about the size of 3 energy gels stacked together. Size and weight, it's really small, really easy to carry. You can carry it in your hand. You can wear it on an armband, which we have. We can wear it on your waist belt. You can tuck it in the back of your shorts and your tights. It's super portable. The IMU sensors I mentioned before are affixed to different places on your body, your lower thighs, your sacrum, via adhesives, and also on your shoes via those running shoe clips you see there. As I mentioned before, the sensor placement is key. You can see there some of the names of our MPIs, which we'll get into in a minute. Smoothness, thigh swing speed, strike angular range, heel pitch, and recoil angular range. The reason they're placed in different places for each of those is to collect the data that will then be converted into the algorithms that give these coachable metrics. But obviously, having those and those key places correlates to those MPIs. Soon we will have the ability to have the LEOMO Motion Viewer, which will then integrate with Google Wear operating system apps. So basically, you'll be able to see all of the data from the LEOMO app on a device that you might have already, for example, a Suunto watch. The Type-S comes in 2 different kit options. The Type-S unit is the same, but there's 2 different versions regarding the sensors. So obviously the kit with 2 sensors versus the kit with 5 sensors allows you to collect more comprehensive data with the bigger package, slightly less with the smaller package, just because you're limited on the placement on the body and the data you can collect in any one session. One of the keys to the Type-S is the web application. Obviously, once you're done running, you can upload all of your data, and then you can view it in many different ways, just as you would view it after any kind of workout. It's really your starting point for comparing and reviewing all this, and you can look at it one at a time or cross-analyze, compare multiple workouts at a time, and certainly compare also the running MPI data. So you could compare, for example, as runners, we're preparing for a race, you might have an 8-mile tempo run you do once a month and compare your fitness and your results with that. This is a great way to do that, and also take into account the running MPI data. So you can really understand kind of how your form is playing a role in your performance, your improvement, and your progression. There's 4 sections of the web application. The first is a GPS map that shows you where you ran. Also, there's a section for basic run data, as I mentioned before, which includes elevation, run cadence, stride length, pace, heart rate. Then one of the key sections is the 3rd section, which is the running MPI line graph. You can really get a visual sense of your performance based on these running MPIs, which ultimately are specific segments of your gait. And so once you understand kind of how those are working, you can look at that and you can see where you might have spiked or how consistent you were late in a run or in a workout, when you fatigue, you can understand kind of how the MPIs, meaning how those sections of your gait might be consistent or might be faltering. The final section is more of a raw data section. You can see averages, max values, min values, and really kind of do a deeper dive into all the data from your workouts. Live Video Sync is a product that LEOMO launched several years ago. It really gives the ability to integrate with the running MPIs and video capture. So to see the runner moving in real time, or on the screen rather, you can understand each of the elements of the MPIs and the data in a video format, which is really key. Obviously, if you're shooting from the side or shooting from behind, depending on which MPI you're looking at, you can get a really good understanding of how those work. LVS works with our Type-S device, which I mentioned, the Type-R device, which is a device we launched a couple years ago. And all it really takes is an iPad camera to record that video. And LVS subscription plans start in $20 a month, and there's a variety of plans, starting with basic and going up to advanced. I'm going to turn it over now to Joe Cavaretta, who is going to give the presentation on the running MPIs, and then we'll conclude after that with a brief discussion about Type-S again, and then answer questions. So thank you very much, and Joe, it's on to you.
All right, thank you very much, Brian, for the introduction to the new running app for the LEOMO Type-S. I'm really happy to be here to introduce the actual running MPIs from LEOMO today. And just want to say it's great to see some familiar faces, some familiar names in the participants. Good to see you guys. Glad you could join us for this today. I'm happy to be walking you through some of the story behind these MPIs, what they can do, what they're measuring, how to apply them in training, how I've been using them as a coach. Lots of ways to unlock hidden potential that we really didn't have the opportunity to be able to measure or visualize before. So I'm really excited about this. So just a quick introduction background on myself. As Brian said, my name is Joe Cavaretta. I'm a sports scientist at LEOMO. I do a lot of work with physiology and biomechanics. I currently coach a running group centered in Boulder, Colorado, a small group that I keep up with here. And it's really great to be able to apply some of these amazing tools that LEOMO is developing in real time with athletes, be able to see it in action, be able to see the discovery of so many different traits and in athletes' minds that they hadn't been able to visualize or paint a picture on or put numbers on various elements of their form in the past. Going through that journey as a coach and also a runner myself has been really fantastic and quite monumental in my development as a coach and an athlete. So I'm really happy to share this with everybody today and hopefully give you some ideas on how you can get started doing the same. Also, one final note, I've also worked as a strength coach to several elite runners, triathletes, cyclists. So, another element I really like about LEOMO, breaking away from only cycling focus, is now we've got various tools in the running MPIs and in the live video sync application that we can apply in really a full spectrum of performance scenarios for sort of a more holistic athlete development, in the gym, in their drills, in their pre-workout routines, in their actual training, and then reviewing data. We really have a full process that we can integrate these tools into, and it's been really effective. So I want to just start with one question first here. It seems like the right place to begin our discussion today, and that is, why is motion important? This is a really interesting question when we think about it. Sometimes the answer in the past has not been so clear or easy. The way I like to think about it, the way we've really been tackling this at LEOMO is to think of it in two categories. We have our, what we call the golden goal, which is our sort of like optimized biomechanical technique, motion of some of the world's best. If we think about, I don't know, I'm sure a lot of people here watched the Sub-2 project where Eliud Kipchoge went under the 2-hour mark in the marathon for the first time in history. And that was just so amazing to me to watch. His speed and form at such an unfathomable pace for that distance looked so smooth and effortless. And I couldn't help but notice even some of the pacers that were around him didn't always look so good as he did. And they were only running 5 kilometers at a time at that pace. You know, it's clear that he just possesses another level of performance, another level of motion. And it's something he's achieved through several decades of training and mastery. And, you know, another example is, you can see in this picture, Wilson Kipsang. You know, he's another one where you take a look at his race pace, you know, running the marathon, previous world record holder in the marathon. And it's such a high output, but he looks so smooth and almost like he's floating, right? And I can tell you, just having seen that in person up close, it's quite breathtaking. It's one of the most amazing things I've seen in athletics, is somebody being able to achieve such a high power output for so long and make it look so easy and effortless. And the interesting thing was, even at his easy paces, you know, jogging, warming up, just going, you know, his what's easy aerobic effort for him, kind of the same visual impact. You know, it's very easy, it's very smooth, it's very effortless. And, you know, we couldn't help but think, like, how can we achieve something like this? How can we start to put numbers and start to put measurements on what makes these runners possess this, like, you know, sort of next level element to their technique and their performance? And luckily, with LEOMO's Golden Goal MPIs, we can now start to measure some of these characteristics and train for it. The next part of this is our sort of train and maintain, as we think of it, LEOMO theory. You know, it's really nice to watch these super elite runners like Elliott and Wilson be able to put up these amazing, almost superhuman performances. But I know for myself and for some other runners that, you know, that might not be something that I can readily jump into and start to mimic and achieve right now. You know, the first step is to kind of understand where I'm at right now and begin to build some resiliency and build some strength and build some skill to be able to maintain the form that I have first for longer durations from start to finish. You know, part of being able to maintain good form is not just achieving the good form, it's being able to maintain it. I have to, if I'm gonna run a marathon, you know, say a 3-hour marathon, and I completely start to break down at the 2.5 hour mark, that last 30 minutes is gonna be very difficult. And I'm gonna lose a lot of efficiency. I'm gonna completely potentially change the way that I'm moving, the way that I'm trying to achieve that pace. That's becoming increasingly more difficult. And a lot of that loss of efficiency and loss of speed, it can be attributed to some of those changes in movement. So realistically, what I want to do is, first, I want to be able to go the distance and be able to hold the best form and technique that I can. When I can do that first, I can know that I'm preventing unnecessary wasted motion and wasted energy from developing when I fatigue, when my mind starts to wander and I lose focus, when I have to make changes in the race, like position, I have to make a surge, I have to get around a group, I have to change direction, things like that. So this is really a whole nother element to LEOMO's theories on training, is providing tools that are useful to help us understand how we break down and how we change our motion, how our behaviors differ at different speeds and different training scenarios when we're under high loads and interval workouts, or when fatigue sets in on long runs. So these are going to be kind of the first two areas to start with. And as we move down, these are sort of 3 areas: efficiency, injuries, and maintaining form, that I'd like to sort of segment some of these areas of thought into. You know, so these are things that when I'm training motion, when I'm thinking about biomechanics, when I'm thinking about how I can optimize my technique to perform better, these are 3 key areas that I'm focusing on. Efficiency, first and foremost, just the cost to produce a certain output. When my form breaks down, the cost to keep that speed up starts to increase. You know, in that marathon scenario, the 2.5 hour mark, if I start to break down and lose my form, the cost to keep that speed is going to increase a lot. And that is energy that, 1, I'm wasting, and 2, at that point in the race, that I don't have a whole lot of to be, you know, just dispersing out in places where it's not going to be useful. With LEOMO Run MPIs, you know, it's nice because I have more tools to start to measure these features with. And when we talk about running economy, it seems all of the research, there's all of these different things that we look at, all these different movements of the body, right? And, there is a sort of like a complex model there. It's not just one trait. There's not just one magical feature that we can measure and say, yeah, that's gonna, if you do good here, you're gonna have a really good performance, you're gonna have good running form. The key is to get a picture of a lot of features of the stride, see how the whole body is moving in space, and see how we're tolerating various stresses to be able to know how we're maintaining and how we're producing that kind of more global economy. So the nice thing about LEOMO MPI is we've got multiple sensors. They go on different parts of the body. We can look at, not just how the foot is moving or how the pelvis is moving, but we can get a sense of how all these different key areas of the body are moving together and in relation to one another. And that's really, in my opinion, that's the key to efficiency, is understanding and maintaining that. When we get to injuries, the biggest risk of injury is changes in movement. When we get into a different movement pattern, perhaps, maybe it's fatigue, maybe it's, an off season, going back into the in season and jumping into things too quickly. But basically what happens, we undergo these changes in movement, and we start to get into these patterns of movement that our body isn't used to. It's not acclimated to. We haven't developed around those ranges of motion or those various forces that we're encountering. And that's when we can sort of unintentionally overload our bodies without realizing it. And that overload that exceeds our current tolerance is what can start to put us at risk for injury. So the nice thing about these MPIs with LEOMO is we can track these changes in movements. I can know what my typical movement numbers are. I can know when I'm fatigued, how they're going to change. I can start to make some recommendations on training based on when the fatigue is high from a biomechanical standpoint, as opposed to just sort of estimating it based on, mileage, subjective measures, things like that. Really having these numbers and being able to detect some of these more subtle changes where, maybe at the time, if I'm an athlete, maybe I'm, a little bit unsure, a little bit on the fence, a little bit subjective about, where I'm at as far as fatigue and fitness go. And seeing some of these numbers can really help to back that up and give me a little bit more confidence in the ways that I'm feeling and in the ways that I want to train. So those are great tools for injury. Another quick point on injuries is recovering from injury. I've actually had a couple different cases of runners I've worked with where, they went through an injury cycle. They kind of came back to full strength. And what they had learned from that is trying to understand what had changed in their motion when they were injured became kind of difficult for them without having numbers or something to sort of paint a picture of that. And so a nice practice that I've been doing now with some runners is taking a baseline test or a baseline measure of how they move when things are healthy. And when we start to see large deviations from that, or maybe they go through an injury cycle, and we're going through this rehabilitation, we can start to see, we have a target for where we want to get back to. And we can create measurable progress and sort of measurable timelines that's based on real data as opposed to, a little bit more subjective assessment. When we talk about maintaining form, this is sort of what we talked a little bit in the last slide, but really just training to maintain our movement patterns is going to help us develop into better, more resilient, and more skillful athletes. This is a component of almost every other sports. And prior to this, there really hasn't been a whole lot of talk about this in the running world. Of course, there's very technical running events like, 100-meter sprints and things like that. But when we talk about distance runners, when we talk about long-term, sustainability of motion, when we talk about tracking changes with fatigue and minute details, it's not something that, has really been talked about a lot. And I'm really happy to be changing the conversation on that, offering some more tools for us to be able to introduce this to runners so that they can begin to work towards these same methods and goals. So just like in swimming, throwing, jumping, we now have some numbers, we've got some metrics, and we can start to move a little bit better and pay a little more attention to this. So, that's a whole lot of information about, just background on motion and background on how we move and how we train. A little bit of a simplified way to look at it. I like to use these 4 points to answer a question of how, what should we train for with movements? If we have all these variables with biomechanics, how do we sift through it? How do we simplify the model so that it's something that I can use with a lot of runners, or if I'm a runner, something that I can take and digest and think about it when I look at my training data or when I'm out on a training run. So for me, these four most important variables, if we think about these first, it can really provide a nice foundation and an easy entry point for starting to look a little bit deeper into some of this motion and these biomechanical ideas. So first one is unrestricted movement around our hips. We can see in this picture of Wilson, he has one hip pretty fully extended, one hip is flexed and forward. What we need to be able to do first is move in the right places and be able to achieve the amount of movement that we need for training. When our movement is limited, our output demand, and when our movement is limited, but our output demands more movements, more often than not, we will compromise and have to compensate with less desirable, less efficient movement patterns coming from other places. So this is step one, is just to be able to move well around the hips, especially because that's our power center when we're running. Number two is stable, smooth control of motion at our hips. For this, we must be able to anchor our hips so that we can move forward smoothly and so that we can generate force through our limbs. When we have more erratic or uncontrolled motion at the hips, very jerky, very up and down, side to side, this can lead to a lot of wasted energy, a lot of less efficient movement. So really the hips are our center of mass in the body, and that's really the key spot that we're trying to move well and move forward at a high speed with the least amount of wasted energy possible. Number three is high force production and tolerance. Basically, speed requires force, and sometimes for really long durations. So to get faster, we need to be able to produce force or lower our barriers to force production and expression, as I say. Sometimes the ability to produce the force is there, but we're not really accessing it well. Maybe we don't, maybe we do have restriction around our hips and we're not able to get into that position that we need to really be able to generate force really well. So this is going to be a key necessity to especially improving speed and being able to get faster across your race distance. And the last one here is maximal utilization of elastic energy. Elastic energy is basically energy that is stored in the stretch components of various parts of our body. And it sort of allows various body parts to act as a rubber band. When you stretch a rubber band and release it, we get this sort of free energy as it contracts. And we have a lot of components of our body that can utilize the same method. And so maximal utilization of elastic energy gives us more free energy and allows us to essentially, go farther, go faster with the same amount of energy or less. Okay, so with all of that background, let's get into what these actual running MPIs, LEOMO Run Motion Performance Indicators, consist of and what they're measuring and how we can use them. So to start with this, I want to sort of break down the phases of the run stride, just get a general idea of what it is we're dealing with, what do we see when we're running, what is it that we're actually trying to measure, and what are the movements we observe. So here we have a pretty typical breakdown of the running stride phases. We see some common terminology, things like swing, ground contact. Within these two categories, we can break them down even further, a little bit finer granularity. This would be considered a little bit more advanced categorization or advanced breakdown. We'd have initial swing, the mid swing, the terminal swing. And ground contact, we have various phases, initial contact, toe off, even divided up into a little bit more of like how we generate force, absorption, propulsion. Right now, to date, we can identify these various phases, but there haven't been a lot of tools available to be able to measure these well, especially in training scenarios. Of course, you can go to a biomechanics testing lab, and they can provide some insight. Those are not super readily accessible across the country, but if you're a more serious athlete or a coach, we can certainly find one. We can pay money and go in there, and they'll be able to do some analysis on how you're moving. I think, in my personal experience, the major challenges here have been taking that data that they can provide and applying it and making it a little bit more actionable for a coach and an athlete. It can be very technical. It can be very minute and also global. There's like tons and tons and tons of data, and it can almost be overload to sift through it and figure out what is it that we actually need to focus on when we're out on the track doing these interval workouts or when we're out on the path doing these tempo runs. So really what we need, and what I really like about the LEOMO MPIs, is it's a little bit more actionable. It's a little bit clearer. We've sifted through some of these different phases of the stride and identified, what are these key areas that we want to measure and what's going to be digestible in training and racing. So I'm going to go through 3 levels of the metrics that we offer on the Type-S. And these are basic, advanced, and MPIs. So with the basic metrics, of course, we have cadence, pace, stride length. Cadence is the number of steps you take per minute. Pace is, of course, number of minutes to cover a mile or a kilometer typically. And stride length is going to be the distance you cover on each stride. So these 3 metrics here kind of generally form the core foundation of some of the numbers around running. Of course, like, pace is probably the #1 thing that competitive runners are focusing on all the time. It's a way that they track how much work they're doing, how fast they're going, things like that. So these are sort of like our entry-level foundation. These are the most common. These are what you're going to see in a lot of different places, talked about in different books and running forums and communities. Our next metrics are the advanced metrics. These ones a little bit less common, but things that you may have seen before here and there. These are a little bit higher level. You might have seen them in a running book or a running magazine article write-up. With these, we have ground contact time, vertical oscillation, and landing pattern. Ground contact time is exactly how it sounds. It is a measure of the amount of time that you are actually on the ground on each stride. In vertical oscillation, we're measuring the vertical displacement of the hips throughout the stride. And an important note here, the thing I really like about the vertical oscillation that we measure is we're measuring this from the pelvis itself. So we place a sensor on the hips and we're getting a direct measure of that hip motion. Whereas in some other applications or in some other areas where you can find this metric, a lot of times it's being estimated from the foot or the chest or various other body parts, and they're sort of trying to infer the motion of the hips from it, right? So I really like that, that what LEOMO is doing is directly measuring that motion of the hips. And the final one is the landing pattern, and this is going to talk about your foot strike. It's the amount to which you land on your rear foot versus your forefoot versus the midfoot. And foot strike pattern is very, very commonly talked about in running. The heel strikers versus the forefoot strikers, the minimalist shoes, the barefoot running. Lots of debate, lots of discussion around this. So now, this is an advanced metric that we're also including that allows us to be able to measure and put some numbers on that. And really the key with these advanced metrics is, the LEOMO MPIs can really take these to another level. They allow you to do more advanced analysis with these, be able to relate these to what's happening in the body, as opposed to just looking at something like ground contact time by itself. That can provide kind of limited information. We can make a couple of estimates or hypotheses about what we think is going on, but really without that additional information, it's a little bit of a limited picture. So let's get into the actual MPIs here. As Brian mentioned already, here are the positions of the sensors, the IMU sensors, and the metrics that they'll produce. So like we just talked about, on the pelvis, we have the vertical oscillation, but we also have a measure of smoothness. And I'm going to get into the descriptions and how all of these measures work next. I'll just give a quick overview here. On the thigh, we have the thigh swing speed. And from the foot, we have a whole lot of information that we can gain. Strike angular range, heel pitch, recoil angular range, landing pattern, ground contact time. The bold values here are the LEOMO MPIs. These are things that we have not really ever seen in the past. These are totally new metrics. These have not been done before. And so I understand these can be a little bit new. So what I'm going to try to do is go through each one and give a little bit of a background on it, what it is that we're measuring, why it's important, how you can apply it, and what some values might look like for elite runners and some different comparisons like that. So to revisit that run stride cycle that we talked about before, here's how we've sort of redefined this at LEOMO to make it more meaningful, to make it a little bit more actionable for coaches and athletes, and to be a little bit more understandable and why these different phases matter and what it is that's actually important to measure at these different phases, and where the MPIs fit in and what they cover for this whole stride sequence. So what we can see from left to right, we see a whole stride cycle from toe off to max foot height, peak thigh speed, max shin angle, angle at touchdown, loading, propulsion, and then back to toe off. That is an entire gait cycle. And we can see in the area that our 5 MPIs cover, we are covering the entire stride cycle and being able to pick up and identify and measure characteristics that are happening at every single phase. So we've got recoil angular range happening from toe off to max foot height, thigh swing speed, strike angular range, sort of at that terminal swing and down to contact. We have heel pitch, interacting with the ground, and we have the characteristic of smoothness and how we're being able to maintain the center of mass motion through all of these different actions. And so let's get into these a little bit more specifically here. Let's start with, well, a brief summary actually. LEOMO MPIs allow us to look deeper. What I was just saying, some of these other metrics that we've had in the past, ground contact time by itself, maybe vertical oscillation by itself, these provide useful information for sure, but when they're in isolation, when they're by themselves, we can only get a limited view. It's only so empowering and only so actionable to be able to draw conclusions from what we're seeing in those numbers and be able to turn it into performance improvement. And so the great thing about LEOMO MPIs, one, it's gonna allow us to obtain a comprehensive view of the running stride, right? What I just showed above, this entire running stride is covered with different MPI relating to every single aspect of it. So we can see, we're not just measuring one section here and one section here. We're actually covering how does the body move through this entire gait cycle on every single cycle of the running stride. So this allows us to analyze strengths and weaknesses for better training, which is a really, really useful tool I talked about before with not only personalizing training, but also injury prevention, monitoring injury recovery. And this becomes actionable, coachable feedback on form and efficiency. Number 2 is this allows for motion tracking and training and racing. Remember that talk about being in a biomechanical lab and how it's, it can be a little bit difficult to extract the useful information that we need from that. The other limitation with that is we're in a lab, and that's great and all for a lot of uses, but having worked in a lab for many years myself and doing this testing, between the lab and when you actually get outdoors onto the track, a lot of things can change. The lab is a very controlled environment. You've got a specific focus on your mind to try to do this test and be able to do it well. You're not really thinking about, how do I run an interval workout? How do I need to pace this tempo run? How do I need to think about my leg motion or my torso motion as I'm on this long run and I'm starting to get fatigued? The great thing about these MPIs is these are metrics that we take with us, that we're actually going to be able to test athletes and just be able to use in training to improve performance when we're out on the track in these real life scenarios. The other nice thing about these, like I said, is this real life scenario application combined with our MPIs adds a lot of value to these advanced metrics we talked about before. So now it's not just ground contact time, it's how does our ground contact time change because of all of these other motion variables in a real training environment. So to start with our first MPI, let's take a look at strike angular range. This is personally one of my favorites and what I think is a really powerful metric for runners because prior to looking into this, I had found this cue and this sort of concept to be rather difficult to convey in a clear way and to be able to grasp as a runner as you're running. And so what we're talking about here with the strike angular range, we can see 2 positions here. We've got this sort of maximal farthest forward position of the shin and the foot, and then we have the position of the shin and the foot as they touch the ground. This maximal shin and foot angle, if we take the angle of that relative to the ground, we've got the maximal shin and foot angle. We call it the maximal shin angle, maximal shank angle. It's the farthest forward point in the stride. If we look at the second picture, the ground contact shin and foot angle, we see the shin angle at touchdown, right? And so the key here is that from this first position to this next position, what's happened is the foot has has reached a far forward position, sort of what I think of as a loaded position, and it has had a chance to swing back towards the ground before striking the ground. And so why is this important? What are we talking about here? Well, first of all, I think of this as the start of the run cycle and sort of the preloading period for force production. What's happening when we get to that far forward position is we're in a loaded position. We're creating tension in the posterior chain and the hips and the hamstrings and the leg. And that is sort of like a position of readiness. We're ready to generate power. We're ready to generate velocity. But what we need to be able to do is pull that leg back and be able to initiate that cycle before striking the ground. So what happens is a higher range, if we can reach that maximal shin angle and pull it back towards us before hitting the ground, it allows the shin and the foot to reach a higher velocity prior to contact. And this higher velocity results in more force production at contact ultimately, and more energy to send us forward. So, what should we aim for? We should aim for a higher range for more propulsion. If we think about what some elite athletes have done, what some real data from the field looks like, one example that I really like is Dennis Cometto when he set the world record for the marathon in 2014. I remember watching this and just a really powerful stride. Anybody who's going to run sub 205, even though they may look very light and fast, these are very powerful athletes. They're generating a lot of power into the ground and a lot of force for propulsion on every stride to be able to keep up that speed for so long. So they've actually done some measurements on when he set that world record. His strike angular range was measured at about 8 degrees average for the full race, which is quite high for an elite athlete, even for a marathon runner. So, if we look at different types of runners, power runners, sprinters, track athletes, marathon runners, sort of more endurance focused people, we can start to train them to create more propulsion and be able to sustain it for whatever their race distance or duration is. So our next one is heel pitch. Heel pitch is another really interesting metric. This one particularly has to do with how we are interacting with the ground. It's a measurement of how quickly the loading of the a little bit technical here, but bear with me for a second, I'll explain it. This is a measurement of how quickly the loading of the vertical repulsive force occurs and how quickly it is transferred to the phase that converts it into propulsion. The way that I can sort of visualize this with runners is, with some runners, with maybe a little bit more novice runners or runners who don't have as much ability to transfer energy well, we can sort of see this lag happening on the ground. It's sort of like they hit the ground. Sometimes it looks a little bit more like the ground hits them. And there's a little bit of a delay as they're moving over their stance leg, and being able to translate that force into something that's usable and propulsive. And when we look at really elite runners, they operate almost like they're on springs. They hit the ground, it's very active, and they immediately translate that force and be able to move quickly over that leg, load themselves, and transfer it into propulsive force. And so this is a really, really interesting graph here. This is, again, a little bit technical, but this is some of our raw data. And I like to show this just because I think it's a pretty powerful example, even though it can look a little bit complex with some different lines and colors and graphs. But basically what we can see here is we have got two marathoners. We've got a 203 and a 207. So very high level marathoners in both of these athletes. Some people would say very, very, very small detectable differences between them. And if you just watch the two of them run visually, yeah, they probably look very close to the same. The nice thing about with our sensors and with these MPIs is we can detect very small differences, even at that high level, to be able to provide tools that can give you, that really fine look, if you're looking for it, into, what's holding you back and areas where you can improve. So the basic idea of this graph here is we can see this at the bottom, this contact time on this first vertical line on the left here. That's when they strike the ground. And then as they're moving forward over it, we can see the 203 marathoner on this purple line, they ramp up and start to increase and achieve their max propulsive force a little bit faster than that 207 marathoner does. So, you know, even when this is even at the same speed and cadence, you know, we might think that those two basic or advanced metrics were maybe something that was enough to differentiate these runners previously, but we can see that there's these really important detectable differences. And if I'm, you know, that 207 marathoner and I'm looking to improve my speed to be able to knock 4 minutes or 5 minutes off of that time, these are the types of things I need to be paying attention to. These are areas where I have area to improve and I've got sort of unlocked potential. So why is this important? Sort of summary of what we just went over. A runner has to be able to hit the ground and quickly store and release elastic energy. And these elite runners in general, we can see they're able to store this energy faster. And what this results in is a faster transition and transfer to propulsion and a better score. And this allows us to, you know, when we're comparing across cadences, you know, runners at the same cadence, runners at the same speed, this provides an entirely different element that we can see as a differentiating factor that's a key factor to pay attention to, because heel pitch can also be affected by various other elements of form, you know, especially things like fatigue, and being able to maintain this force production and this transfer of it for, you know, if I'm a 207 marathoner, 127 minutes is going to be really key to being able to use, you know, my engine and what I have available as energy to its fullest. So what should we aim for in general? A lower score, and also maintenance of our scores for longer durations, like I just talked about with fatigue. Some elite athlete data here, we can see the 203 marathoner, a 218 marathoner, and a 235 marathoner that we've been able to test here and gather some data on. And like we just talked about, you know, these are all high-level performers in their sport. These are fast runners. These are technically proficient runners who pay a great deal of attention to how they train, how they recover, how they move. They're in the gym. They're doing strength conditioning training. They're doing movement drills. And what we can still see here across these three increasing paces, we've got 352, we've got 320 per kilometer, we've got 258 per kilometer, which is definitely getting up there. You know, even across these three marathoners, we can see some differences in how they're able to tolerate, generate force, and transfer it into usable forward energy. So the 203 marathoner has a little bit of an edge over the other two. It's definitely something that stands out as something they've been able to refine that's helped them achieve the level that they're at. You know, there's only a few people in the world that are, you know, 203 marathoner, and those differences that can separate them are not only really important, but, you know, very minute sometimes. Our next one is recoil angular range. So what we're seeing here in this picture, we kind of talked a little bit about this in the stride overview. We've got this position at toe off, and then we have the highest position of the foot in the stride. So in this first picture here, we can see the angle of the shin at takeoff as the toe is about to leave the ground. And so this angle here is sort of our starting point. When we look at the second one, the maximal shin angle, this is the foot at its highest point. And if we look at the angular range of the two, you know, sort of the distance that that foot travels through that angular range between these two pictures, that is what we're reporting here. So this is how high the foot lifts after leaving the ground. So why is this important? Foot recoil. This is something that is maybe, you know, of these metrics, something I've talked about or heard about the most as an idea, is this idea of the foot sort of reaching the hips, or how high the foot lifts after leaving the ground, recoiling. In sprinters, you know, we can see they want to try to get as high as they can. Like they say they want to sort of like kick the hips, and they perform these drills, you know, butt kicks, things like that, to try to train that. You know, the key point here is that a higher recoil range makes it easier to swing the leg during that subsequent swing phase. Basically, the shorter the lever arm, the higher you lift that foot, the shorter of a lever arm you're going to have in your leg. And the shorter that lever arm is, the easier and the less energy it's going to require to achieve a faster swing during that swing phase. You know, higher recoil, how does it happen? It's basically the result of better release of energy during ground contact. And so we can already start to see when we think back to like heel pitch and strike angular range, how all of these MPIs, you know, they can be interrelated. They can be dependent on each other. We can start to, when we segment that stride, we can see, okay, you know, I have really good force loading and production in the strike angle range, but then my recoil angular range might be a little bit lower than expected, right? That means maybe I'm not using and transferring that elastic energy well. So the really nice thing about these is we're starting to paint a picture here of how all of these different things integrate and how we can start to measure it and draw conclusions from it. The height of the foot recoil, this is also an important point. This can be related to the timing of the swing. Timing is something that so many run coaches and biomechanics specialists have talked about. And for myself, in my experience as a runner training, it can also be one of the hardest things to try to teach myself. Thinking about, you know, multiple things synchronizing and timing up correctly, it can just be a lot to think about. And really just to have a tool in the form of a score that I can monitor in training and I can review after training, it makes it much easier to conceptualize this for myself, and also to be able to start to design drills and ways to sort of break this down into simpler movements or patterns that I want to train, and be able to focus on this specific trait. So what should we aim for? A higher recoil range for better release of energy and timing of your swing, like I just mentioned. And also, of course, maintenance of your range for longer durations. With the elite athlete data here, we've got our 203 marathoner, we've got a 218 marathoner, and we can see some numbers. These are, you know, roughly 332, 338 per kilometer pace, 320 per kilometer pace, 255, 3 minutes per kilometer pace. So for these guys, this is, you know, kind of easy, a moderate tempo, and a little bit fast. We can see across both of them pretty good numbers. This is what I would consider pretty high ranges. They're really just in general, you know, they're getting pretty high recoil range. They're using that elastic energy pretty well. Where the interesting points come in here is for each of these runners, we can start to look at things like how symmetrical am I? Is there one leg that is not releasing this energy or transferring it well as much as the other? You know, as I train, as I get into a longer run, do I start to see this like asymmetry develop greater? Do I start to see other changes in the height, things like that? So with a good point here is, you know, with the 218 marathoner, at these different paces, the relationships between them are not always constant. And you can see some, at certain paces, there's a little bit greater asymmetry. At other paces, maybe a little bit more of a habitual training pace. Maybe the asymmetry lines up, it becomes a little bit more symmetrical. You know, so this can be really specific to how you're training. And that's a powerful tool for me because it's not, you know, in building a resilient or a well-rounded athlete, we can't just look at where we always train. You know, we've got a couple, certainly as runners training for a specific event, we've got these areas where we tend to focus a lot of energy and attention in our training, specific paces we fall into, right? And I think part of being well-rounded is having a scope for how things change when you get a little bit outside of that. Because I don't know about you, but you know, for a marathon, I am not running the exact on-point same pace from start to finish for that race. You know, what happens is you've got a range. You've got a little bit, some periods where you're a little bit below your goal pace, some periods you're a little bit above the goal pace. And if I don't take a look at some of those other possibilities that I'm going to be encountering in training and racing, then I'm really limiting my scope to only what I think is ideal or what I think is, you know, going to be the reality in the race, when that may not be the case. So the key here is, you know, look at different paces, see how things change. It may not always be the same relationship or the same type of data that we expect to see. Moving on, we have thigh swing speed. And this one is pretty much exactly how it sounds. It is the maximum speed of the thigh as it swings forward on each stride. We can see in this first picture, we've got a runner who is in stance phase, and that lifted leg is at its highest recoil point. And what's about to happen is that leg is going to thrust forward as that stance leg takes off from the ground. And this is a really powerful action for generating energy to move forward. So why is this important? Well, as I just said, thigh swing speed helps create forward energy on each stride. And this swing thigh, like we just showed in that second picture, it's not just the leg that's on the ground that is helping us drive forward. It's a combination of the actions of this leg swinging forward at a high velocity simultaneously with that leg on the ground generating force that allows us to be able to achieve faster speeds and be able to transfer energy better. So this is a really key metric. A reduction in thigh swing speed can also indicate changes in the height of our foot recoil and also the timing of our swing, things we just talked about with the recoil angular range. If our recoil of our foot starts to decrease, or if it's a little bit lower because we have an asymmetry in that side or we're not using energy as well in one side, that can change the speed we're able to achieve with the thigh on that next phase of the run. And it can also change some of the energy costs of being able to swing that leg at such a speed. So this is a really key metric to measure from an energy standpoint as well. Asymmetries, of course, this is a really big one for me because asymmetries on thigh swing speed can point to weaknesses. And this can also include the opposing leg. Like we just talked about, this sort of synchronization between the leg that's on the ground and the leg swinging forward is a really key motion for being able to generate power and energy and propulsive force to be able to send ourselves forward. And when we see big asymmetries develop, sometimes it's the interaction of those two things that we can start to gain some information about how that foot on the ground is generating force. If it's not generating force well, sometimes we'll try to spike our thigh swing speed to try to sort of jerk ourselves forward or create a little bit more force to help balance things out and keep us moving. So what should we aim for? A higher speed to maximize forward energy, as we just talked about, and maintenance of this score for longer durations. The elite athlete data here, this is an interesting case. These units are in degrees per second. And so this is technically, this is going to be a measure of angular velocity as the thigh is rotating around the pelvis. So degrees per second is the unit for these numbers. In the 203 marathoner, we can see some pretty high values, 392, 400. Progressive speed, we see that thigh swing speed getting faster as they're creating more force to create that speed. And also, I would say overall for the 203 marathoner, pretty symmetrical numbers. In general, in my experience, this is this is a very detailed metric. We can really, really pick up imbalance as well. Most runners have at least some degree of asymmetry at a low level. The problem comes when we start to see that symmetry or asymmetries grow and get a little bit bigger, or if we see a large asymmetry on one side or the other. In this 218 marathoner, also a high performer, a little bit different information we can collect from this. We have pretty similar overall values on average, but we see a pretty large asymmetry between the left and the right sides at all speeds. And for this runner, it's something that they want to look at this is potentially lost energy production. This is essentially lost force production in one half of the stride on every single stride as they run a marathon, which, is going to be well over 100,000 strides. So this is an area where we need to be thinking about how these small differences add up through thousands and thousands of cycles to be able to impact our race performance. Our fifth metric is smoothness, and this is measured from the pelvic sensor on the hips. And this measures exactly what it sounds like, the smoothness of the hips, specifically in the lateral motion. So this is sort of an interesting concept. Lateral and lateral rotational movement of the pelvis is quite common in running. And this is something that is often identified as like hip drop, when the runner hits the ground, or hip lift, once they hit their hip flexion and they're taking off of the ground. The bottom line is that the hips move laterally, the hips move rotationally, and this impacts how we transfer energy and how we create energy in the stride. Going back to our very early slide about those four components of what's important, the second one down was being able to move the hips in a smooth and stable, controlled manner. And this is exactly how we measure that. This is describing how we're able to maintain control and coordination of all these movements around the center of mass to keep our hips and our center of mass moving forward smoothly. Runners with hip imbalances, mobility issues, strength imbalances, oftentimes this is a really, really great place where we can start to detect those things. So why is it important? To summarize, it reflects dynamic control of movement. That has to do with how a runner, it's not just what these movements are, but it's how we are able to control them and maintain coordination with lots of these other movements that are happening around them. So more smoothness, which is reflected as a lower score, reflects an athlete's ability to maintain coordination and synchronization of motion as they're running. So this data sample here is actually pulled from our web dashboard, and we can see this is a tempo run divided into 4 sections. And what I'll often do with runners during key workouts is split up their run or their work sets into different quadrants to take a look at how things change across that interval or that tempo or that long run. And so we can see here, these are pretty good values. The scale closer to 0 would be considered a perfect score. These are pretty low. I would consider this moderately in control. But we can actually see as the run goes on, we go from 36 starting out to 38 to 42 by this 3rd quadrant. And then as they start to reel it in and bring things back to focus as they finish, we drop down a little bit to 40. But what I see here is this is a marathon runner running at marathon pace. And it's absolutely crucial to be able to maintain this control of movement at your pace for longer periods of time. So if we see this drift going up, oftentimes it can be due to fatigue. Sometimes it's as simple as they're not thinking about it, or they've sort of allowed their mind to drift away from the competition or what they're trying to do in the moment. And being able to have a tool to monitor that in live time, bring it back into focus, so that they can finish strong is really a really nice tool. So what should we aim for? Basically lower scores, and then maintenance of the smoothness for longer durations. Now, this graph here is pretty interesting. This is just what we see down at the bottom, a 2:03 marathoner and a 2:18 marathoner that we've used in some of these other case scenarios. And we're running at the same pace for all of these intervals. This is 3:52, 3:20 per kilometer, 2:58 per kilometer, right? And so when we're looking at this data, we see a really interesting separation at this higher intensity, 2:58 per K. At these lower intensities, 19:35, 24, 42, and then a very clear threshold as we jump from 3:20 to 2:58, where the 2:18 marathoner really just loses a lot of smoothness and control. And the way to interpret this, having seen this play out in person, one of these runners is working a lot harder and is sort of above their threshold for capacity to be able to move well, to be able to achieve this speed. So when we look at these two numbers at this last stage, 35 versus 140, that huge separation, the 2:03 marathoner is able to run even these really fast paces and be able to stay in control. They have a really good, really well-developed motor control and coordination of their movement, even under really high loads. Whereas this 2:18 marathoner, this is definitely an area of improvement. We see this very clear threshold. What we know is, okay, if we're trying to train at this 2:58 per K pace, this might not be, this might not be a really good place to be able to be training better movement patterns to integrate at easier paces. If we're constantly, overreaching above this limit and basically teaching your body to move this way, to be a little bit more jerky and a little bit more, a little bit less synchronized and a little bit more kind of just straining overall, then some of those movement patterns are going to translate. We're going to start to lose that ability at some easier paces. So this is really a key area to differentiate performance and a key area to identify, where should we be training? Not just like what paces are we hitting, but how are we hitting those paces is the most important thing. So I want to revisit this slide, and so those are our LEOMO MPIs, and we've gone through each of them. We've given a summary. We've kind of talked about what they measure and individually how they work. I want to go through a couple of cases, a couple samples of data, and show some examples of what it looks like when we put it all together, and what sorts of coaching decisions and what sorts of ideas and methodology that I've started to implement in my own practice that can, I think, be a useful tool for people who are looking to introduce this to their own practice. So going back to this, obtaining a comprehensive view of the running stride. Like I said, it's not about just looking at one key feature all the time. We need to understand how everything is fitting together. You know, one run stride happens pretty fast, and it can be kind of difficult to just visually pick out all these different things that are happening at once, right? That's why we have these metrics. That's why we have this nice web dashboard, as is shown here, that can show different efforts you do. It can show the MPIs over time. It allows tons of different analytic tools that allow you to zoom in and get a closer look at specific portions, do cross-analysis between specific MPIs, look at pace and cadence, along with all of the GPS data, see, you know, uphill versus downhill, how do changes in cadence affect these things, how do changes in speed affect these things. So what we can see in this specific case, we have several stages repeating 400-meter interval at increasing speed the entire way. Every single stage was a little bit faster than the last stage. And I really like this as a test to not only just test sort of like general, you know, runner capability, but to be able to, you know, observe motion trends with increasing speeds. And with increasing speeds, we have increasing load, like we saw in the last slide with smoothness. Sometimes runners hit a threshold point where things start to break down rapidly and they start to completely change their movement in the name of achieving a certain pace, because that's what, you know, their training plan said that they had to hit. And that, you know, could be based on just, you know, various, you know, previous, you know, training that they did or suggestions they got from a book or things like that. But the nice thing about this is we can go deeper and start to individualize. So just by observing these motion trends with increasing speeds, we can start to identify where are the weak points for this specific athlete. Are there thresholds that we hit where some of these values start to plateau, where our force production starts to plateau, where we start to lose control of our motion and start to break down on a global sense. And this is nice because then we can also measure and track imbalances at each of these paces as well. So like we've been talking about before, you know, not just where are these imbalances, but how are they changing with different intensities and different loads? Going all the way back to that first slide, thinking about injuries, when we undergo changes in motion, that can potentially put us at risk for increased injury, because now we're in a different movement pattern that we maybe not, you know, maybe we haven't acclimated to or we haven't trained to. And it can be very easy to exceed our current tolerance there. And so when we see something like in this slide, the thigh swing speed down here, with increasing speed already down at these easier efforts, we can see a little bit of an asymmetry is already there. But certainly as we increase the effort and increase the load, we start to see that asymmetry grow a lot. And for runners, we know the majority of their training is spent at these easier efforts. This is where we are most well acclimated to. At these higher efforts, these are more like interval efforts, high intensity. We don't really spend a whole lot of time per week there, you know, when compared to our total training time. And so it's likely that if we see something like this, we haven't developed or acclimated really well to some of these different movement patterns up here. And when things start to break down and we see these asymmetries grow, we need to think about how we're training and how we can start to address these individual needs a little bit better to not only, you know, reduce our risk of injury or changing our motion, but also to think about how we can really optimize our motion from a training standpoint. You know, we think of runners will commonly have a lactate test done or a metabolic profile in a similar fashion. We want to see with increasing intensity, you know, what is the physiology doing? How are we tolerating this? And at some point, when we're doing a lactate test, we're going to see our lactate threshold, that point where sort of these physiological markers start to increase dramatically. And how do we improve that? You know, oftentimes we train a little bit below that threshold. We don't want to, we train, you know, at it or a little bit below it. And what it does is it improves the tolerance to that load and it pushes that threshold farther out. And the same thing can be applied here in these biomechanical sense, where we can start to use tests in a similar way, see where we have these breaking points. In that smoothness case, or in the smoothness case here, you know, we can see around 315 per kilometer, we start to see this kind of dramatic rise in the smoothness, a loss of smoothness. This combined with all the other data, you know, we can clearly see we're exceeding a certain tolerance at a certain point. And so when we think about that, you know, how do I improve not just my engine or my physiology, but how do I improve my biomechanics to be more efficient without sort of overdoing it and putting myself at risk? I want to find that threshold, and I want to be able to train really close to it or a little bit below it so that I know I'm maintaining the highest load that I can while maintaining good form. To move on to our next point, just motion tracking and training and racing. This one is very simple, and this dashboard is one that I particularly like to come back to. It's a nice example of a marathon runner performing a marathon tempo set. And this is at their target marathon pace. We can see this is the one that I showed earlier, divided into 4 quadrants. We can see this work set, part of the warm up here, cool down, and then the center work set. So, it's not all just about, having good metrics and monitoring injuries and programming training, but in a more proactive sense, thinking about the event itself and how we're going to perform at the event. I really want to have a good picture of how I am moving and how I am producing that force and that effort at my goal race pace. So I like to take, once we have a little bit more of a broad general overview, like that last slide, we can see, how do things change with speed or cadence, across the board. I then like to take a little bit closer look and say, okay, what is it we're trying to achieve here? If the goal is to run fast or run this pace for 2.5 hours for a marathon, I want to know exactly what our tolerance is to be able to do that. Does our motion break down after 1 hour, and we need to be able to over double the amount of time we can hold that? That's a big task. And that's only going to be achieved if we can measure and track and actually focus on training that form in our training and in our lead up to it. My key point here is the focus of the workouts, especially when we get into race specific stuff. It's not just about the pace. It's not just about hitting my splits for the marathon. It's about the quality and the efficiency of how I'm doing that and if I can maintain it. Really, it's just training with a little bit more purpose. So to sort of get towards the end of things here, and hopefully, you've written down all of your questions. We'll get into those at the end. I want to present just a simple case. You might be thinking, okay, I'm a little bit, I'm a runner. I take my training seriously. I've got a few different, I've got a watch. I use GPS. I try to track my mileage really well. You might be thinking, okay, how can I step into this realm of motion? How can I use the Type-S and get started with it to start to build up some of these skills and be able to start to track my training at a little bit higher quality? I'd like to offer 2 simple options as an entry point for people who are new to this type of thing. Option 1 is a 4-stage test. You basically just run 60 seconds at 4 different speeds. That would correspond to like an easy aerobic effort, a marathon effort, more of like a tempo feel, a threshold effort, which depending on your speed could be half marathon to 10K, and then also a 5K effort, a little bit more, a little bit higher speed, a little bit higher load, kind of pressing on those limits of tolerance. And the reason I like this is just you run 60 seconds at each of these efforts. It can be done, it's very low taxing. It can be done preceding a speed workout just as a warm up, as a check-in maybe, just to see how things are looking that day. And the next option would be to do a little bit more, a little bit finer granularity and look at several different paces from easy all the way up to your maximal speed. For this, I like to use about 8 stages of increasing speed. You can certainly do more. You can go as high as you want and look at these with fine granularity. But these are 2 ways that I would propose if you're new to this and if you're just getting started with the Type-S and the MPIs and you want to just start to get a motion profile. How does my motion look? How should I start to look at this data and understand, what are my weaknesses? What should I focus on? How does my motion change? This is a really easy starting point. So let's look at an easy case of this applied. So this is a 2:35 marathoner, and so we've seen some of their data already in some of the previous slides. This is a runner who takes their training very seriously. This is somebody who is a little bit new to training with motion, and so doing just the 4-speed protocol was a really simple method for them to just get into the track to get ready for an interval workout. Doing this as sort of like the tail end of their dynamic warm up and their prep to get ready for that higher speed. Performed we can see here, this is a snippet from the dashboard. These are some of the MPI summaries. And we can see in these different columns, we've got easy pace around 7 minutes per mile, marathon pace around 6 minutes per mile, threshold around 5:40 per mile, 5K pace around 5:20, which, you know, actually is a little bit closer to 10K pace for this runner. It's somewhere in between, but nevertheless, it's a relatively high speed for them. And sorry for the American or non-American runners out there. This slide is in American units per mile. I prefer per kilometer personally. But what we can see from this test, so we're looking at these 4 different efforts. What we want to see is some increasing values. I want to see if things plateau. I want to see if we've got low values that stick out anywhere, lower than they should be. And I want to see if we've got asymmetries that are asymmetries at sort of easy base pace, and then asymmetries that would develop greater with increasing intensity. To pull out just a few examples from this case here, if we start at the top, we've got ground contact time there, looking at recoil angular range, looking at strike angular range and thigh swing speed. As we get to the threshold pace, and then we move faster by about 20 seconds per mile, we see these values just plateau. This runner is hitting some sort of limits. Probably they are utilizing their full capacity for elastic energy return and release. They've sort of hit their limit, and they're not able to build on that to achieve these faster paces. So what we see is these values kind of stagnates, and the ones that really stick out, ground contact time, you know, basically if that's not decreasing with increasing speed, we're having to make a lot of other changes in our stride to lengthen out the stride to be able to build that pace. And when that isn't something that progressed in these easier paces, going from easy to marathon, marathon to threshold, you know, we've basically entered a new movement pattern. And we're at this top end, we're changing what's normal for us to try to achieve these higher speeds. In the recoil, same thing. With an increase in speed, we should see an increase in force production on the ground. We should see a little bit higher release of energy at takeoff. And really, we actually, technically, both of these values decreased a tiny bit. So also not ideal. In the strike angular range, first of all, just relatively low values across the board. Really under 3 degrees is quite low. It's not really ideal for force production or actively loading the leg prior to hitting the ground. The problem with that is sometimes, maybe some of you can relate to this, sometimes you watch a runner and it almost looks like the ground is hitting them. And I think that's the easiest way for me to describe what I see with low strike AR values is these runners are basically reaching that farthest forward point in their stride, and they're immediately hitting the ground. And they're not having a chance to preload the leg, generate some tension, generate some force and velocity before hitting the ground. And it becomes this very passive way to try to create forward propulsion. And so these low strike AR values stick out to me as definitely a key indicator that we need to work on actively generating force. And then also this final point at the bottom is smoothness. These, you know, if we go back to our other marathoners, the 218, the 203, you know, values in the 30s, 40s were a little bit more common, you know, especially at like really fast speeds. Here we see 95 to 140, which indicates that this is very jerky, erratic, sort of unsmooth, uncontrolled motion. So this is something that we definitely want to address too, because we're losing a lot of energy in this lack of smoothness. So here's sort of, you know, me as a coach, working with some various runners, also applying this to myself as a runner. Some of the things that I like to employ as a process for this is, one, we'll do this test, very simple. I'll gain an idea on where do we have some limitations, where do we have some weaknesses, where do we have some asymmetries and things that we can focus on. And then we'll kind of start with some strength and stability work. In this specific case, we talked about sort of low force production and unsmoothness being 2 of the key findings from this athlete. 2 big areas of need if we're going to advance that marathon pace past its current at 2:35 per marathon. So the big thing is strength and conditioning for runners should not be random. Oftentimes it is. It's just kind of the idea that going to the gym and doing stuff is going to make us a better runner, but really there are times when this can actually do more harm than good, when we're not really taking into account what the purpose of that session is. And for me, the focus of any strength conditioning work is always to improve running motion and not to inhibit it or limit it further. And you know, there's various ways. A lot of times it's just observationally based. A coach or a runner may think, you know, I kind of feel like my leg is doing this thing, or I feel a little weak here. I'm just going to go and start doing squats and try to fix this up. Sometimes, you know, it's sort of like throwing the dart with the blindfold on. Occasionally you're going to hit the board and have some good results, but more often than not, you're going to miss kind of wide. The nice thing about these MPIs is we're eliminating some of that guesswork. Based on this simple test that we just did, it took 4 minutes, it was 4 sets of 60 seconds, we already have a very clear picture of specifically what we need to focus on. And so from this, we can create a little bit more targeted strength programs based on individual weaknesses. For this individual, in this case, it's increasing the strike angular range to preload on each stride and create better propulsive force. I mentioned that was a big, you know, low values the entire way, a big limiting factor in the overall speed production. The next one would be movement control in the hips. We want to create a smoother stride and reduce some of that wasted energy that we're losing. So then the next step, once we've sort of addressed that, would be to take this stuff sort of out of the gym or off the mat and start to put it into practice and create these patterns, because working on hip stability or working on this targeted movements in the gym, you know, at some point we need to translate it to what we actually want our body to do when we're running. And so I call this create better patterns. And this is nice because with these MPIs, I've been able to program more specific drills based on the MPI data that we see. For this specific runner, we want to increase strike angular range and we want to improve smoothness. The drill we go to for that, just as an example, the B-skip drill, which is a common track drill. And this allows us to focus on generating speed and force into the ground before we strike the ground. And simultaneously, we're building powerful hip drive, but also focusing on keeping that pelvis stable and smooth. These drills are nice because it's a controlled environment where we can really kind of tune into these very specific details we want to improve. Obviously we have limited time and limited energy to be able to, you know, we have all this training we have to do. We have all these things we want to focus on. You know, we can't just be guessing and trying to hit everything with a blanket approach. Oftentimes we just need to focus on the details that matter the most at that time. And so the way that I like to implement this is just in the pre-workout routines, in the dynamic warm-ups at the track before we're doing a track session, based on the, you know, individual runners and their weaknesses and their motion that we find. Their dynamic warm-ups can look a lot different. And if we're going to spend 10 minutes doing drills, I want to make sure we have a heavy emphasis doing 70 or 75% on just the things we really want to improve. There's no sense in sort of just, you know, doing a heavy amount of maintenance work just to be able to keep something that's good already good. We need to really focus on improving these spots where we have potential to improve and not just sort of hitting everything at the same time. So then the final step would be to train with motion and integrate this into our actual training and our actual running workouts. The nice thing is with the Type-S and with the watch application, these metrics can be reported in live time. This allows us to set workout goals specifically, you know, based on specific parameters of the stride or specific MPIs we want to focus on, and not just monitor them, but we can set these goals for workouts. And there's actually a tool that LEOMO will be releasing as a feature very soon. It's unfortunately not released yet. We're still finalizing some details, but this is going to be called the LEOMO Target Range. If you attended some of our previous webinars, you've seen some other presenters like Sebastian Weber, Adam Hansen, sort of touch on this idea and this new feature we're going to be offering. And basically what it can do is allow us to monitor our baseline or our target or our goal for that workout and get notified when we're starting to break down or fall out of whatever values we want. I'll get into more on that on the next slide. Basically though, when we're training with motion, the goal is to use these metrics to improve our motion and be able to sustain it. In this run here, in this example we see from before, this is a tempo run. We can see it divided into 4 quadrants. And this is this runner, you know, their weaknesses in strike angular range and smoothness. these are, you know, for this runner, these would be maybe we go to the track or we go out for a tempo run, and we can kind of program not just, hey, focus, you know, the common cue that I've seen is like, hey, focus on technique. A lot of coaches or a lot of runners have heard this, and they're just kind of like, you know, what does that mean? Like, you know, you can tell me focus on my form, focus on my technique and run well. But if I don't have some specific goals within that, I'm not going to be really effective in the work I'm doing. So one example would be in this case, yeah, let's focus on strike angular range and smoothness for this workout. Let's be smooth and let's generate some force into the ground. And if it's a tempo run, I want to focus on hitting our values and sustaining them. If it's an interval workout, we might want to focus on hitting some higher values for strike angular range and you know, while trying to maintain our smoothness. This is sort of like training and testing just under greater demands, and you know, providing a little bit of focused, controlled overload to be able to target these lower intensities. So let's talk a little more about this target range. This is a really powerful feature where, you know, basically a runner can set parameters or can set a goal for an MPI or multiple MPIs and say, I want to maintain my smoothness within this range. Let's say 40 to 50 or 30 to 50. And that's going to be my goal for this workout. And we can fine tune how wide that range is, what we want it to be as a coach. You know, you can work with your coach to set goals and say, you know, how precise do I need to be right now at this point in the year? The really great thing about this is you'll get notified from the watch or from the app on the Type-S when you're falling out of this range. And so what we can see in this graph, this smoothness graph at the bottom is, this is another tempo run of this runner. And you know, if we kind of follow this, this blue line showing the smoothness, we can see if this red box is above it, that's sort of like too high of a value. And this blue one would indicate that we're sort of below the range. Now, for something like smoothness, you know, for me, obviously the lower the score, the better. Always, you know, there's no bottom limit that I want to achieve there. But that, you know, to just say, hey, do it as low as you can isn't super actionable for me as an athlete or a coach. I would rather say, okay, our normal value fluctuates around 40 to 50. Let's set a goal to be on the lower end of that range or to be a little bit below 40 for this next upcoming run. And so we can set our target range at, you know, maybe it's 35 to 40 for this run, and we want to see how well we can maintain that. Or, you know, with the different MPIs, certainly we'll want to not change things too quick. But be able to work around what's normal for us and make those small changes to start to work ourselves towards more optimal values. So if we look at the smoothness graph, we can see, you know, this is slowly increasing smoothness in this first quarter and the second quarter, all the way up until this kind of first big spike where it goes up into the red. You know, think of it as almost halfway through, maybe like the runner's kind of settled in, his mind starts to drift a little bit, or fatigue starts to set in. You know, all of a sudden that smoothness value starts to jump up. The Type-S gives a notification and says, hey, bring it back down. Let's get back into our range. This type of feedback is something that, you know, a coach at a track, you know, we can sort of start to monitor it and you know, give some cues and things in live time. But, you know, I don't generally follow a runner on their tempo run for every step of the way. And, you know certainly not able to previously quantify like these minute details of how smooth their running is or how much range they have in their recoil or things like that. So this is a really great coaching tool that I can work with an athlete, help them set goals. An athlete themselves can take a look at what their normal values are, start to make small changes to work towards better values, and then be able to train that and get feedback in live time for when they start to fall out of that range and, you know, get fatigued or things like that. So one other quick case, I'll just run through the summary of this one to show another use case. This one is a 3-hour marathoner doing the same type of 4-stage ramp. We've got easy pace, marathon pace, a threshold pace, and 5K pace. What we can see here, the big findings for me, as we increase the speed, we see a pretty large asymmetry develop in the recoil angular range that was not there at the lower efforts. In the strike AR, we see sort of a same idea of an asymmetry developing to be a greater asymmetry with increasing speed, and also pretty low values across for that strike AR. And then in the smoothness, actually a positive point for this runner is they have pretty good smoothness values across their speeds. And so this is, it's not all about just picking out the weaknesses. It's also taking a look at what do we have going for us? Where are our strength points? We should work to maintain those while working on our weaknesses. So for this runner, just kind of summary, the big thing I'm going to focus on when I see something like a big asymmetry develop, first I'm going to take a look at mobility and strength, especially starting with the hips. A lot of tightness or limitation in movement around the hips can result in a limited strike angular range, just because a runner may not be able to achieve that high maximal shin angle before they strike the ground. That could be due to limited hip flexion, pelvic position, things like that. And then also the other thing I take away from this is that energy doesn't seem to be releasing well on that leg, which is resulting in this sort of lower values for the recoil angular range. And so I want to take a look at how they're moving, if there's limitations in their movement that are preventing them from hitting this optimal range that they need to create force and transfer it. So the simple summary here, for this runner, I'm going to focus on some mobility and strength at the hips, increasing the symmetry and the recoil angular range, increasing the overall values of the strike angular range. And I want to be doing this while I'm maintaining the smoothness at the hips. I definitely don't want to sacrifice that. I want to make gradual changes so that we can change some of these ranges of motion and how we're creating force and transferring it without negatively impacting other things. Nice thing about this is, of course, with LEOMO target range, we can monitor multiple variables at once, or we can choose one to focus on in their actual training. So thank you very much. I want to turn this back to Brian to just sort of close things out, and then we'll also start to address some questions.
All right, thanks, Joe, very much. I appreciate it. Obviously, we've had a lot of people online watching this, and certainly these resources, these links, we encourage you to go to. At this point, I think we're going to go into a Q&A session now, so we will start that here momentarily.
Let's take a look at the Q&A. All right, here we go. All right, so let's go to the top here. Let's see, first question. Joe, do you try to alter runners' form based upon the data coming from the LEOMO sensors? Yeah, this is, I would say yes, we are trying to optimize the form, but how we do it is the really important part. We don't want to just like suddenly go in there and make huge changes that are going to change the entire way they're moving. Doing that too suddenly, like we talked about, can overload different new movement patterns, in ways that they're not acclimated to. It could be a little bit too aggressive. So, you should definitely take into account what phase of the season you're in. If you're in a really high training period, peaking for a race, it might be a better time to focus on just sustaining the motion that you have and focus on being able to sustain that motion at your race pace. And then when you get into a little bit more flexibility in the off season or the preseason, those are more times to start to address areas where you can improve and start to make small changes over time. Let's see. How many people were used for those data points? In general, at LEOMO, we've tested hundreds, if not thousands of runners. The data points that I'm showing here are all specific use cases from specific runners we've worked with. So in the slides here, those are just specific cases. Let's see. There's a lot, this is a good question. There's a lot of focus on endurance runners here. Are the Run MPIs useful for higher speed events? For instance, the 400 meters. Yeah, this is, thanks Andy, this is a good question and one that definitely have discussed a lot in the past. First and foremost, definitely these metrics are designed with the endurance runner in mind, but there are certain applications where we can make this work for more middle distance, definitely, and even some shorter distance runners like in the 400 meters. The main limitation is gonna be we want our sample of data that's long enough to really give a good value and a good average for what's happening. So if it's 5 seconds or 10 seconds, that might be a little bit too short of a window to actually get a good picture of how those things are happening really fast. And the other thing is just sort of at really high intensities, basically like getting back to like the 100, 200, you know, the sensors are optimized to be able to capture pretty high impact forces, but sometimes at really high accelerations, some of the data can get a little bit tricky. So I definitely recommend it for distance runners, middle distance runners for sure, and just a little bit of a cautious application when we get into sprinters. I think 400 meters, you know, looking at 40 to 60 seconds type of sets is absolutely possible. Let's see. Is there any metric that works similar to dead spot score presently available or in the works? I would say our closest metric we have is the smoothness metric here. This shares qualities with dead spot score in that dead spot score is quantifying pedaling smoothness. And we're similarly looking for this neuromuscular control and coordination of the body's movements in being able to impact that score. And so that is the same in both cases. As far as a dead spot score from the foot, it's a little bit different in running. So we've had some ideas, but presently we are focusing on that smoothness at the center of mass because I find that to be a little bit more impactful right now. Let's see. Let's see, smoothness, 2:35 marathoner. Let's see, mentioned 39 to 40 is very good. This runner must be very bad. What is the actual range? What is a realistically good range? So this is quite individual to different runners. That kind of point of that slide with a 2:35 all the way down to a 2:03 marathoner is to show that we can have pretty big contrast in smoothness values across runners, even at the high level. I would say the strength of elite runners is they're able to maintain their normal values at under a little bit more intense load and at higher speeds. But we still see, you know, if you watch a marathon race and you look at the front pack, there's all sorts of different levels of smoothness and running, you know, gait patterns going on there. Some of these runners are really smooth and optimal to the likes of an Eliud Kipchoge or a Wilson Kipsang. And some of these other ones are up there, you know, mainly because they have a really big engine and maybe their movements don't look the best. For them, you know, they would probably have a really high smoothness range. Even though they're running a pretty fast time, their smoothness is really bad. And to me, it's not, you know, it's more that they are achieving that performance in spite of their lack of smoothness. And it's an area where if they had access to it, they may be able to be even faster if they applied that energy better. Let's see. Would you be interested in suggesting running drills that can work on particular problems that we've identified in the MPIs? Definitely, we can expand on this more. I provided one example based on the strike angular range MPI, but this is something within our team that we're always discussing, how to translate this into track drills and things that are a little bit more focused that runners can work on. So I think we'll probably put something together here in the near future, some sort of blog post or another webinar maybe to just talk about suggested running drills that directly can affect and be identified with MPIs. Let's see. Lots of great questions here. Is the target range available? No, that will be available very soon. I appreciate everybody's patience. We've just been finalizing some of the last details of it. And that's going to be available not only for cycling, but also for running. So especially if you're a triathlete, all of these same principles are going to apply on the bike. And actually a really nice addition to what's already being done in the cycling world in the application of triathletes. Let's see. Yeah, thanks. Thank you, Sergio. Product looks amazing. Ready to start using it. This did launch today. So you should receive an update on your Type-S and be able to implement these running MPIs immediately if you have a Type-S. If you don't have a Type-S, definitely head over to our website and get some information on how you can obtain one. These are available now. Let's see, do we have some answered already from our team here? Thanks a lot for that. Yeah, I think one final question. Do we have examples of improvements by athletes using the Type-S? So we do internally with the athletes that we've worked with and with the athletes that I've been able to work with. Some of them are shared in this presentation. With this just going public and being released today, we're hoping to see lots more examples of these improvements shared with us from our users and our interactions with them. So we'll definitely be following up with more specific cases of improvements, showing different ways of using it, different ways that, different cases, specific cases we might run into using the Type-S. But I think this is opening the door now for everybody to start creating their own use cases and examples of these improvements that they can see with their own Type-S. All right, so I think that covers most of our open questions. Thank you all again for the tremendous questions, your attention, and your engagement through all of this. This has been really exciting for me to share with all of you. I'm really excited to engage at the next step as all of you can start using these metrics, start understanding a little bit more about them in your own applications, start creating your own analysis and use cases. This is going to be really exciting to see. So I just want to hand it over to Brian one last time for any final announcements he may have.
All right, thanks again, Joe, and thank you very much for everyone who has attended here. A few post presentation notes here. We will be sharing the presentation via email after this and also on social media. So if you need to see that, you can look for that. We have all your emails from your registration. Also, we are giving away Type-S in a sweepstakes. We have 2 more drawings to go. So you will be contacted by email on how to register for that. And so if you register, we will be doing drawings. I think the next one is on May 11th. And so you can win a free Type-S Sensor Kit Pro. In the meantime, certainly please follow us on social media and also go to our website, leomo.io, for more information, all the updated information about both our run and bike technologies on here. And so certainly we're excited for this day. We appreciate you joining. Certainly we are in now cycling, running, and triathlon. And as we continue forward as a company, we are excited to venture into other sports as well. But certainly being able to launch the running MPIs today was a very big deal. And we appreciate your interest and your questions. And we look forward to seeing you on social media and in follow-up questions.